My dear students, today in this video I am going to start the CBSE Class 11 Mathematics subject. In this video, for CBSE students studying, those who are studying 11th standard, I am going to start the subject mathematics in this video, and in that subject, the third chapter, Trigonometric Functions, is the chapter I am going to introduce now. For that, I know that you have been studied already in your 10th standard some trigonometric functions, about trigonometric functions. Simple functions, sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta, like that. The definitions of that sine, cos, tan you have studied already on the basis of that, and before going to that trigonometric functions directly, first I am going to introduce the relation between degrees and radian. Degrees and radian. Consider the unit circle with center horizon. Unit circle means the radius is 1 unit. That's why it is called a unit circle. In this unit circle, the center is horizon, this is x-axis and y-axis. And the circle is divided into 4 quadrants. The plane is divided into 4 quadrants. This is the first quadrant, and this is the second quadrant, and this is the third quadrant, and this is fourth quadrant. In the anti-clockwise sense, you have to define the quadrants. See, this is the starting point 0 degree, and it is in the 90 degree, and here 180 degree, and it comprises 270 degree. It again coincides with the 0 degree, that is 360 degree. One complete rotation gives you the 360 degree. 360 degrees gives you the one complete rotation. Since it is a unit circle, the circumference of the unit circle is 2 pi, because our radius is 1. Therefore, 2 pi radians is equal to 360 degree. R is 1 unit, therefore 2 pi r is the circumference. R is 1, therefore 2 pi radians is equal to 360 degree. Therefore, pi radians is equal to 360 divided by 2, that is 180 degree. Pi radians is equal to 180 degrees. 2 pi radians is equal to 360 degrees. That is the relation between degrees and radian. And to convert the degrees into radians, degree measure, you convert the degree into radian measure, you have to multiply the degree value by pi by 180. You multiply pi by 180 into the degree given, gives you the radian measure. That is first formula. Similarly, second one, to convert the radian measure, radian into degrees. For that, you have to multiply the radian value into 180 by pi. That is 180 by pi into the radian value gives you the degree measure. Example, 90 degrees. I have convert this 90 degree into radian. Therefore, for that I am multiply pi by 180 into 90 degree. 90 divided by 180 is 2. So pi by 2 radian. 90 degrees is equal to pi by 2 radian. Similarly, 3 pi by 2 radians into degree. Second one, radian measure to degree. You have to multiply the radian value by 180 degree by pi. Degree measure equal to 3 pi radians is equal to 180 by pi into the radian value. 3 pi by 2. Pi cancel, 2 and 90, 2s are 180, therefore 90 into 3, 270 degrees is the value of 3 pi by 2 radians. Like that, degrees and radians are to be determined using these two relations. You convert degree into radian, you have to multiply by degree into radian. You convert the degree value by pi by 180. Similarly, to convert the radian into degree, you multiply the radian value by 180 by pi. So, using this idea, some more degrees and radians I am going to give now. This is the second quadrant. See, degree 0, 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, and you will see radian. 0 degree is radian is 0. 30 degree, 30 degree. So degree 30, 5 by 180 into 30, 130, 630 is 180. So 5 by 6 is 30, radian of 30 degree is 5 by 6, 180 by 6. 45 is 5 by 4, 445 is 180. 60 is 5 by 3, 90, 5 by 2, we have determined already. And similarly, 90, 180 degree, 180 degree is equal to, pi radian, 270, 3 pi by 2 radian, 270, 3 pi by 2 radian, and 360 degree, 2 pi radian. That's all. This is the radian measure and degree measures of some values. 0, 30, 40, 90, 180, 270, 360. You remember these values, and now I am going to introduce the trigonometric ratios. See, one more result you remember. 1 radian equal to 180 degree by pi. 1 radian equal to 180 degree by pi, that is equal to 57 degrees 16 minutes approximately. 1 radian equal to 57 degrees 16 minutes. Similarly, 1 degree equal to 5 by 180 radian, that is equal to 0.01746 radians. 0.01746 radians approximately. This is also radian approximately. These two results you have to remember. 1 radian equal to 57 degrees 16 minutes, 1 degree equal to 0.01746 radian. And now we will see one by one. First I am going to give the introduction of trigonometric functions. See, the first quadrant, you consider this is angle x, and the distance is, this is the point P, radius 1 unit, this is x and this is y, you can say. Angle is 1 radius is equal to 1 unit, therefore sin x equal to opposite by hypotenuse y by 1, that is equal to y. Cos x equal to adjacent by hypotenuse x by 1, that is equal to x. So the point P is x comma y. That is nothing but cos x comma sin x. X is cos x, y is sin x. See, always a point represented in the trigonometric functions. In the trigonometric functions, the x coordinate is always represented by cosine function, and the y coordinate is always represented by the sine function. This is an important point you have to remember. X coordinate is cos x, y coordinate is sin x, because y is sin x and x is cos x, because radius is 1 unit, you remember. So any point on the coordinate plane represented by x coordinate by cosine cos x and y coordinate by sine function. You remember this point now. Next, similarly, tan x, you know, tan x is opposite by adjacent. Opposite side by adjacent. Okay, the other is sin x by cos x. Tan x is sin x by cos x. This is equal to y by x. Y is sin x, x is cos x. So we can say tan x is sin x by cos x also. And the reciprocal of sin x is cosecant x is 1 by sin x. And reciprocal of cos x is secant x is 1 by cos x. And the reciprocal of tan x, cot x is reciprocal of tan x is cot x, that is 1 by tan x, that is equal to 1 by tan x, that is equal to cos by sin, cos x by sin x. So these are the 6 ratios: sin x, cos x, tan x, cosecant x, secant x, and cot x. You remember all these 6 ratios you have to define like that. The coordinate plane is always represented by x comma y is cos x by sin x. Next, coming to the quadrant system. Next, I will define the quadrant system. Coordinate system, that is unit circle, center is origin, then this is first quadrant. In this first quadrant, all the trigonometric ratios are positive. All the trigonometric ratios are positive. And in the second quadrant, sine is positive, and tan and cot is positive in the third quadrant. Fourth quadrant is cos positive, cos and secant. So first quadrant all positive, second quadrant sine and cosecant, it's reciprocal. Tan and cot in the third quadrant, fourth quadrant cos and secant. Gives you the positive sign. So it is given by a formula, all silver teacups. You remember this? All silver teacups. First quadrant all positive, second quadrant sine and cosecant, third quadrant tan and cot, and fourth quadrant cos. To remember the positiveness of the trigonometric ratios in the quadrant system, you remember this expression, all silver teacups. All first quadrant, silver S for second quadrant, tan T for third quadrant, and cups C for fourth quadrant. In the first quadrant, we can find below 90 and above 360. 90 minus theta and 360 plus theta. These two are in the first quadrant. These two angles are represented in the first quadrant. Second quadrant, we can find, what is it? 90 plus theta and 180 minus theta. This is in the first quadrant and this is in the second quadrant. In the third quadrant, 180 plus theta, 270 minus theta. These two angles are present in the third quadrant. In the fourth quadrant, 270 plus theta are 360 minus theta. These angles represent the fourth quadrant. So in each quadrant we can define two angles, two set of angles, 90 minus theta and 360 plus theta in the first quadrant, 90 plus 180 minus in the second, 180 plus 270 minus in the third, 270 plus 360 minus is in the third quadrant. First we will see one by one. First we will see the angle ratios of minus x or minus theta. Ratios of minus x. Ratios of minus x. This is C. I will consider a unit circle. This is horizon, x-axis. This is the y-axis, horizon. See, this is angle x, P, XOP, the same angle. See, in the anti-clockwise direction, the angle always represented by positive. In the clockwise direction, the angle always represents the negative sign. So this is minus x. So we have to find out the angle of ratios of minus x. Minus x is in the fourth quadrant. See, I already told you, anti-clockwise directions, angles measured along the anti-clockwise directions are positive, and angles measured in the clockwise directions are negative. That's why in the protractor also we can find the angle from right to left in the anti-clockwise direction. Positive angles were there. And we have got that positive angles from right to left. And in the clockwise direction, the angles are represented by negative sign. Therefore, so the minus x is in the fourth quadrant. Minus x is in the fourth quadrant. In the fourth quadrant, you know what is that? Cos and fourth quadrant, cos and secant are positive. Therefore, sine of minus x, fourth quadrant, sine negative. Therefore, minus sine x. Cos of minus x, fourth quadrant, cos positive. Therefore, cos x. Tan of minus x, tan in the fourth quadrant negative, therefore minus tan x. And cosecant of minus x equal to, cosecant is also negative, minus cosecant x. Secant of minus x, secant is also positive in the fourth quadrant, therefore it is secant plus secant x. And cot of minus x, cot is also positive, negative, therefore minus cot x. This is the ratios of minus x. The values of ratios of minus x is this. You remember this set of values, and these are very much used in solving the problems. Okay. And I will stop here, and I will continue the concepts in the next video. Thank you.